Welcome to this explainer. Look, if you've been tracking the AI space lately, you know exactly how it feels. It's like we're literally drinking from a fire hose. Between new models dropping every single day, random AI labs springing out of nowhere, and the constant rapid shift in the tools we use, the noise level is absolutely chaotic. But as an analyst, my job isn't just to regurgitate the news for you. It's to cut through all that noise and deliver the actionable insights on the macro trends that are actually reshaping our digital landscape. We've got a week of massive shifts to cover, so let's get right into it and break this down step by step.
Okay, let's dive into this. We're going to use a 5-part analyst framework to structure this whole chaotic news cycle. We'll be looking at market consolidation, the open source challenge, the creative workflow revolution, efficiency and infrastructure, and finally, the physical AI frontier.
Starting off with Section 1, Market Consolidation. Developer autonomy versus vertical integration.
There is massive tension building in the developer ecosystem right now as the proprietary giants move at just breakneck speeds. Based on recent back-end routing logs, OpenAI is already doing controlled evolve tests on GPT 5.6, and we're expecting a dedicated codex model for Agentic workflows in just a matter of weeks. Google, they aren't sitting still either. Their cloud CEO just confirmed high confidence in internal benchmarks for what we expect to be Gemini 3.5, which is gearing up for an I/O launch in literally 21 days. Now, to see how this macro squeeze actually impacts developers, just look at Root Code. It was wildly popular, over 3 million installs, but it's officially shutting down so the team can go all in on a new cloud agent called Remote. It's a perfect microcosm of the industry's squeeze toward vertical integration, especially after SpaceX's acquisition of Cursor. But we do still have independent holdouts. Take Code. They're staying independent, totally open source, and they've actually completely rebuilt their VS Code extension with parallel agent execution.
Now, the core philosophy of driving Code really brings us to what's defined right here, model freedom. It's the absolutely crucial principle that developers need the ability to choose the best AI model for their specific task rather than getting locked into a single company's walled garden. Code's open architecture directly supports this. They allow for parallel agent execution, sub-agent delegation, shared sessions, the whole shebang. And this matters deeply, guys, because when the market consolidates into just a handful of megacorporations, your autonomy as a developer is the very first thing on the chopping block.
Moving right along to Section 2, the open source challenge, rising labs disrupting the proprietary giants.
So if the proprietary giants are Goliath, we are suddenly seeing some very well-armed Davids stepping onto the battlefield and staging a massive counteroffensive. Take tech giant Xiaomi, for instance. They just dropped a seriously underrated open-source model called Mimo 2.5 Pro. And if we look at the data, the specs here are just staggering. It's a massive 1 trillion parameter model, but it's highly efficient, using only 42 billion active parameters. It boasts a full 1 million token context window, and incredibly, it's completely open source under an MIT license. That means developers can commercially deploy it and fine-tune it however they want. In recent evals, this thing actually outperformed highly respected models like Quillian 3.6 Plus and DeepSeek V4, taking a top 3 spot among open source models for complex front-end design. To really bring those table specs to life, let's look at what Mimo 2.5 Pro can actually build in the wild. In a complex, long-horizon workflow, this model was prompted to generate a complete Mac OS clone, and it nailed it. It handled complex SVG application icons, fully coded functional versions of Finder and Safari, and get this, it even built a functional Minecraft clone running inside that cloned operating system. No way, right? It just brilliantly proves that free, MIT-licensed open-source models are now highly capable of executing the deep, multi-step coding tasks that used to require a proprietary giant.
But Xiaomi isn't the only lab making waves right now. Check this out. Just one single GPU. That is the entire infrastructure stack that a brand new lab called Poolside AI reportedly used to run their fully in-house trained model. The crucial point here is understanding exactly what they built on that tiny stack. It's called Laguna XS2. This is a 33 billion parameter open-weight mixture of experts model released under an Apache 2.0 license. And crucially, Laguna is engineered explicitly for agentic coding. This highlights a massive macro trend that we're seeing. The market is rapidly pivoting away from generalized conversational chatbots. We're moving directly toward highly optimized autonomous agent systems that actually do the heavy lifting for you.
Which leads us perfectly into Section 3, the creative workflow revolution. From standalone chat to direct application plugins.
As we transition from chatbots to agents, the application layer itself is transforming.
These tools are breaking out of the web browser and literally physically plugging themselves right into our digital workspaces. And this brilliantly illustrates that shift. Claude Code has just released direct connectors into the heavy-duty software that professionals are already using every single day. We are talking deep, direct integrations into Blender for 3D modeling, Autodesk Fusion for hardcore engineering, the entire Adobe suite, and Canva.
Let's walk through exactly how this alters a standard professional workflow, using 3D design as an example. Step 1. You, the designer, issue a natural language prompt via Claude. Step 2. Now, instead of just spitting out code for you to copy and paste, Claude directly connects to Blender to debug the scene, or it builds custom tools natively right there inside the software. Step 3. It then automates and applies batch changes across the entire 3D project. The time saved here is absolutely astronomical. Designers and engineers can now modify and iterate on complex models entirely through natural conversation, without ever having to leave their workspace.
Now, obviously, for these workflows to actually be viable at an enterprise level, the foundational tooling has to be rock solid. So Claude Code just pushed some major quality of life updates to ensure that. They fixed these massive background RAM consumption issues on Linux systems and finally enabled concurrent MCP server launches. Mid-task, they completely resolved that notoriously frustrating please run/low authentication bug that kept randomly prompting users to log in, and upon completion, they've added a feature that sends a push notification directly to your phone when a long task wraps up. Plus, on top of all that, their new /res feature means massive coding sessions, like those with transcripts over 40 megabytes, are now up to 67% faster. Just huge workflow improvements.
Section 4. Efficiency and infrastructure, driving down the cost of local deployment.
To make all these incredible agentic workflows sustainable in the long run, the industry has to tackle a hidden bottleneck, and that's infrastructure costs. Enter hardware giant Nvidia. They just released a brand new, fully open-sourced model called the Neutron 3 Nano Omni. It is a 30 billion parameter hybrid Mamba transformer. What's so powerful about this is that it handles text, video, audio, documents, and charts all within one unified system. And it is specifically optimized to be deployed locally. You can run this on everything from a consumer RTX 5090 all the way up to a massive DGX enterprise system. NVIDIA has totally open-sourced the weights, the datasets, and the training recipes, giving developers complete control.
Directing your attention to the chart here, the efficiency gains for local deployment are just a total game changer. Compared to similar open multimodal models, NVIDIA is claiming a staggering 9.2 times higher efficiency for video workloads and 7.4 times better efficiency for multi-document tasks. When you anchor those efficiency jumps in the actual data, it is crystal clear how significantly this reduces the friction and the massive infrastructure costs of running heavy multimodal agents locally.
But listen, infrastructure cost wars aren't just happening on local machines. They are absolutely raging in the cloud too. As industry watchers note, DeepSeek continues to dominate when it comes to cost efficiency, huge context windows, and making frontier-level capabilities available to far more developers. And this week, they proved it yet again. They are now supporting a massive 1 million token context window directly inside Claude Code, utilizing their DeepSeek V4 Pro model.
And to ensure they keep that cost disruption dominance, they just extended a massive 75% discount on their API for developers all the way until May 31st. This intense pricing war is forcing the entire market to adapt, and it's radically lowering the barrier to entry for any developer wanting to build out complex AI infrastructure.
Let's move to Section 5 and see how this builds into our final topic, the physical AI frontier, when digital intelligence meets retail labor. So up until now, we've basically been discussing digital efficiency, software consolidation, code, APIs. But the ultimate destination for all this advanced AI isn't just a browser window, it's the physical world. For example, over in China, certain retail environments are already moving way past those traditional self-checkout kiosks. We are now seeing the factual, gradual replacement of human cashiers with fully automated AI-powered robotic workers. These systems are handling the entire process in real time, from customer interactions and dynamic problem solving to complete payment checkouts. It's wild. We are looking at a space where the highly efficient, autonomous software brains we discussed earlier are literally being integrated directly into standard labor markets via robotics.
Which leaves us with a pretty critical question to consider as we wrap up this explainer. We've seen how open source models are driving down costs, how agentic workflows are replacing manual digital tasks, and how software efficiency is hitting just unprecedented peaks. So taking all of that into account, how rapidly will autonomous robotic systems transform the physical labor market in the next decade?
It's a profound thought, for sure, and it really underscores why tracking these seemingly isolated digital software updates is absolutely crucial to understanding our collective future. Thank you so much for joining me for this explainer. Keep questioning, keep learning, and I'll see you next time.